Welcome to this explainer. Look, today we're shifting our focus away from the temptation of just rushing to code the perfect AI solution. Instead, we're going to master the structured, evidence-based methodology that assessors are actually looking for. If you want to think, act, and communicate like a lead AI methodologist, you absolutely need a rock-solid foundation before you write a single line of Python or SQL. Let's get right into it.
So, is this AI agent safe enough to deploy? When you get hit with a prompt like this in an assessment or interview, your gut instinct might be to just blurt out yes or no. But I gotta warn you, jumping straight to a definitive answer, it's a massive trap.
Here's the reality. Guessing an answer without context is essentially throwing darts blindfolded. It shows a complete lack of analytical discipline. The winning approach is systematically defining the boundaries before you even formulate your thoughts. You should instantly be asking yourself, deploy to whom, and exactly for what purpose?
To help you nail this every single time, we're going to cover 5 key pillars today: defining problem and scope, designing the initial method, reliability versus AI safety, navigating evidence and limitations, and finally, the final assessment blueprint.
Let's start with part 1, defining problem and scope.
Before we design any solution whatsoever, we have to build an impenetrable constraint box around our problem based purely on available evidence. You've got to lock down the who, the what, and the why. The subject is who uses the AI, right? Like a triage nurse in an ER. The object is what it's applied to, so incoming patient symptom data, and the purpose is why it exists, which is to accurately prioritize urgent care. Listen, if the problem doesn't give you this information, do not make it up. Identify the evidence you actually have and aggressively call out what's missing.
Moving on to part 2, designing the initial method.
Once those hard boundaries are set, you've got to stop trying to build a perfect, fully fleshed out system from scratch. Instead, focus on a practical, initial heuristic design. You don't just pull methods out of thin air. You start with an unchanging principle, something like do not claim safety beyond available evidence. Then you adapt that rule to your specific context, create a concrete method, and validate it using just a small sample set. You're building a best fit baseline, meant to be improved over time, not a finished masterpiece.
Part 3, reliability versus AI safety. Evaluating AI requires forcefully separating reliability from safety. Let's break reliability down into 3 parts, starting with repeatability. Simply put, if you run the exact same input through the exact same model under the exact same conditions, do you get the exact same answer? That raw consistency is your baseline repeatability.
Next up is reproducibility. This tests if your system survives the messy real world. If we introduce variation, like altering the server environment or maybe swapping out the underlying model entirely, does the fundamental behavior actually hold up?
And finally, temporal stability. If your AI model approves a small business loan today, is it going to make the exact same decision on the exact same financial data next month? Together, these 3 metrics, repeatability, reproducibility, and temporal stability, form the absolute bedrock of system reliability.
But here's where people completely trip up. A system can be incredibly reliable at giving you the exact same wrong answer every single time. It's kind of like a broken clock, right? It reliably says it's 3 p.m., but it's only correct once a day. Reliability is just about the consistency of the output. It guarantees absolutely nothing about the actual truth or correctness of that output.
Furthermore, a system can be reliably unsafe. Safety is a completely different axis entirely. It's about weighing the potential benefits against the potential damage. You have to ask yourself, what is the absolute worst-case scenario we're willing to tolerate? Because if you haven't explicitly defined the absolute upper bound of acceptable critical damage, there is no way you can declare an AI system safe.
Which brings us to part 4, navigating evidence and limitations.
A core philosophy of the methodologist is knowing exactly where hard evidence ends and the vast unknown begins. We use 3 discrepancy lenses to spot these gaps. Inside discrepancy looks at our own internal distortions and limits. Interdiscrepancy examines knowledge gaps between different teams or interacting systems. Think of a miscommunication between a medical imaging AI and a hospital's outdated record database. An outside discrepancy represents the complete unknowns beyond our current domain. Now remember, this isn't some magical taxonomy of every possible failure. It's just a highly practical framework to limit your assumptions.
I want you to burn this principle into your memory. Do not manufacture certainty beyond the evidence-supported domain, period. If your data stops, your confidence has to stop too. Extrapolating incomplete data and presenting it as a confident conclusion isn't just bad methodology,
In safety-critical situations, it is actively dangerous.
So, instead of faking certainty, embrace an exploratory inductive loop. Observe, form a hypothesis, build an initial model, test it out, and then revise based on hard evidence. It is perfectly fine to temporarily accept incomplete results, as long as you are aggressively validating them and iterating your approach.
Finally, Part 5, the final assessment blueprint.
Let's bring this all home with the ultimate blueprint for structuring your answers. Don't just spit out a conclusion. Follow this exact flow. State what you know, provide your evidence, and then give your current conclusion. But then, explicitly state your assumptions, highlight the limitations of your approach, and outline exactly what testing comes next. Doing this proves to any assessor that you know the critical difference between an evidence-based fact and a dangerous blind spot.
If you ever get stuck, just lean on these 10 steps. Define the problem, identify the evidence, and set the scope. State your principle, propose an initial method, and test it heuristically. Then relentlessly evaluate reliability and safety, check your test coverage, and finally, state your limitations and iterate. Following this sequence dynamically proves you prioritize logical reasoning over just rushing to code.
Ultimately, it all boils down to this mindset shift. I don't try to produce a perfect answer from incomplete information. I define the boundaries, build the best practical method justified by evidence, validate its safety, identify unknowns, and iterate. Make that your absolute core philosophy as an AI methodologist.
I'll leave you with this final thought to ponder as we wrap up. When your AI is deployed into the messy real world and the hard evidence inevitably runs dry, how will your methodology adapt? Thanks for joining me for this explainer, and remember to always keep asking the right questions.